Welcome to Mathletes. I'm Gori, and today we'll be tackling Pythagoras. I'll be doing every question ever asked in HSC Standard 1 Maths over the last 5 years. So grab a pen and let's get started.
Alright, this is HSC Maths Standard 1. Every question ever asked in an exam on Pythagoras. Let's get started. Question 20. A map of a park containing a duck pond is shown. A fence is built passing through the points A, B, and C around the duck pond. Using the scale provided on the map, calculate the length of the fence AB. Alright, so let's just count up the squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so I count 15 squares. And with our scale, every 2 squares is worth 10 meters. All right, so we just get our 15 squares and we divide it by 2, and that gives us 7.5. And then we take our 7.5 and multiply it by 10 to get what the distance is in meters. So that would be 75 meters. The length of AB is equal to the length of BC. All right, so this length and this length are the same, and they're both equal to 75 meters. 75 meters. Great. Use Pythagoras' theorem to calculate the length of AC in meters. Give your answer correct to 3 significant figures. All right, so our Pythagoras' theorem is a squared plus b squared equals c squared. And we're trying to find out what c is. So just rearranging that, c is equal to the square root of a squared plus b squared, which is going to be the square root of 75 squared plus 75 squared. We're looking for the hypotenuse here. So 75 squared, punching that into my calculator, plus 75 squared, and then we square root it. It gives us an answer of 106.066. And it says, give your answer correct to 3 significant figures. So that's going to be 106 meters. Just checking. Yeah, it's meters. There we go. Question 20. An isosceles triangle is drawn inside a circle as shown. The base of the triangle is 4.8 centimeters long. The length of the other sides is 4 centimeters and the height is h centimeters. Calculate the height h of triangle ABC. All right, since it is an isosceles triangle, we know that it is bisecting the base here. So this is going to be 2.4, and this is going to be 2.4 as well. So we can calculate this height, h, by using Pythagoras' theorem. So a squared plus b squared equals c squared. And just rearranging that, b is equal to the square root of c squared minus a squared. So in this case, c squared is going to be 4 squared, and take away a squared, which is 2.4 squared. So let's punch that into our calculator, and we get 4 squared minus 2.4 squared, and then we square root it, and that gives us 3.2 centimeters for h. The area of triangle ABC is 7.68 centimeters squared. The radius of the circle is 2.5 centimeters. Express the area of triangle ABC as a percentage of the area of the circle, correct to 1 decimal place. Okay, so the area of the triangle is half its base times its height. And we know that that is going to be equal to half times 4.8 times the height, which is 3.2. And the radius of the circle, the radius of the circle is equal to 2.5. Okay, so the area of the circle is equal to pi r squared, which is equal to pi times 2.5 squared. 0.5 squared, so 6.25 pi. So express the area of the triangle as a percentage of the area of the circle. So then the area of the triangle is equal to 7.68 divided by 6.25 pi. So if we just divide those numbers, that will give us the percentage that we're after. 7.68 divided by, and then we open some brackets, 6.25 times pi. And that gives us 0.391139. So to express that as a percentage, it's going to be, correct to 1 decimal place. All right, so it's going to be, as a percentage, 39.1%. There we go. And our height was 3.2 centimeters as well. A hotel is located 186 meters north and 50 meters west of a train station. What is the straight line distance from the hotel to the train station? Round your answer to the nearest meter. All right, so pretty straightforward. Pythagoras, a squared plus b squared equals c squared. In this case, we are after the c. And just rearranging that, we get c is equal to the square root of a squared plus b squared, which is equal to 50 squared plus 186 squared. So punching that into my calculator, I get 192.6032. Round your answer to the nearest meter. Okay. So 193 meters is our answer. Yep. Okay, question 27. Sean is interested in buying a block of bushland. The price per hectare is $500. The land he wishes to purchase is in the shape of a right-angled triangle as shown. The length of the side AB is 7,800 meters and the length of the side BC is 3,000 meters. The right angle of the triangle is angle ACB. Note 1 hectare equals 10,000 meters squared. What is the cost of the block of bushland? All right, so it's simply asking us what's the area of the triangle. And we know the area of the triangle is half base times height, which means we need to find this side right here. So using Pythagoras, a squared plus b squared equals c squared. Actually, I'm going to call this b instead of x. And we're just going to rearrange this. B is equal to the square root of c squared minus a squared. So b is equal to 7,800 squared. take away 3,000 squared. Well, that's a big long number, 51840,000, but we still need to square root it. So we get 7,200 is this length, 7,200. All right, and so then our area is equal to half base times height, which is equal to half our 7,200 multiplied by 3,000. All right, so just multiplying that together, 7,200 times 3,000, and then dividing it by 2, we have 10,800, that big long number. So that's what our area is. Now we need to divide it by 10,000 to know how many hectares it has. So divide by 10,000. And we get 1,080 hectares. Okay, and the cost is equal to 500 times 1080. So 1080 times 500 per hectare. So we get $540,000. There you have it. Question 28. A right angle triangle XYZ is shown. The length of XZ is 16 centimeters and the angle YXZ is 30 degrees. Find the side length XY of the triangle in centimeters correct to 2 decimal places. All right. So this is actually going to be trigonometry. Okay, so we want to know what XY is, and we simply say cos 30 degrees is equal to XY on 16. So XY is equal to 16 times cos 30 degrees. So cos 30 times 16, 13.8564. And we want it corrected 2 decimal places. So 13.86. And it's a side length, so we want to say centimeters as our units. Hence, find the area of triangle XYZ in square centimeters correct to 1 decimal place. All right, so it's simply going to be half base times height, but we don't actually have this length, YZ. And what we're going to do is use Pythagoras to get it. So this one is 13.86. And we're looking for YZ. So a squared plus b squared equals c squared. In this case, YZ is going to be one of our sides. We'll call it b. So b is equal to c squared minus a squared. And that's the square root of that. So YZ is equal to the square root of 16 squared. Take away 13.86 squared. So punching that into my calculator, 16 squared minus 13.86 squared gives us 63.9. Square root of that is 7.99377. Okay, and we want to find the area of the triangle. So the area is equal to half base times height. And our base is going to be 13.86. And our height is going to be 7.9937. Okay, so we just multiply all that together times 13.86, and we divide it by 2. And that gives us an area of 55.3968. And it wants it correct to 1 decimal place. So 55.4 centimeters squared. That's it. Thank you very much.